This video is the second part of the 2017 Higher Level Section A, looking at question A3 and A4. Question A3, design for a patio fireplace based on a regular solid is shown. The drawing shows the elevation and plan of a similar solid. All faces are regular pentagons. Part A of this question is using the given x1, y1, draw the true length of the line of intersection between faces A and B, and hence determine the dihedral angle between the two faces. Part B of this question is to determine the center point of face B in plan and draw the projections of a sphere which rests on the horizontal plane and is also tangential, is in tangential contact with the center point of face B. So starting with part A of this question, we need to find the true length of the line, this line here that joins AB, so it's this one, and this one down here in plan. So we're going to look in perpendicular to that. They've already given us the line x1, y1, which is a vertical line. So projecting each of these points, 1 and 2. It's fairly faint. So just like all auxiliary views, when we're measuring, so this is an auxiliary elevation, so I'm going to take my heights from the elevation. So I'm going to, it's on the line, this line here, so measuring the height of that. Measuring that height here. This point is on the ground, so this is the one that we're marking up. And this here is the true length of the line of intersection between the two faces. So there we have the true length, so that's the first part of this. What we need to do next then is determine the dihedral angle between the two faces. So to get the dihedral angle, you're going to look along our true length line, so we're going to get a point view of it. So sliding set squares, or an adjustable set square if you have one. And out here we have an x2, y2 line. So projecting this line out along here, that point is going, we're going to find these points, they're going to be this distance back. We're going to have to come back to that in a moment. What we have first though is we need to create, if you want, you can take all 5 points on each face, A, B and C. So you could take 1, 2, we already have this one, 3 and 4, and this one, and find all of them up here, and it would create the face for you, but they'd all be in line with each other. So a simpler way of doing this is if we're just to take a part of it, so we're going to reduce down this, so we're just going to take this part of it, so you can kind of see this shiny bit here, and do the same thing for face B. So we're just taking that much of it instead of taking the whole lot. So that would be this point, projecting this point and this point here up into the elevation. So we're essentially just kind of taking that much and this much in here. So it just reduces down the number of points. So you can do that for any surface in any question, unless they ask you for the whole surface. In this case, they don't. So we need to find those 2 points in the auxiliary elevation. So that's in the x1, y1 position. So that's coming off out here. They're on the ground, they're points on the ground. So that lamina would be going from this point back to there. So I'll just draw that in lightly. And then you can project this point from the auxiliary elevation into the second auxiliary. So that's projecting this up along here, and those points are going to be somewhere up along this line. To find those points, just like with all views, so when we were drawing stuff in this view, we skipped this view, measured it from this one. Now that we're working in this one, we're skipping this one, the x1, y1, and we're going measuring from here. So each piece that we're going measuring, I'm going to measure from the x1, y1 line back into the plan. So that's this point here. That's that point. In the line of intersection is the next one that we measure back, So here and here, now they have to be the same distance back. So that's on this line here. And then finally measuring from this point back over here. This is that point. So we can join three of these up together as an edge view of each of the planes. And this point here is a point view of the line of intersection between the two. So this in here, that's the dihedral angle that we're looking for part A of this question. Next part of this question is determining the center point of face B and plan and draw the projections of a sphere which rests on the horizontal plane and is also in tangential contact with the center point of face B. So this is face B here. We need to find the center point. So to find the center point, you need to bisect either an angle, which would be difficult because we don't have a true size of any of the faces. So what we can do instead is if we bisect any one side, so if I bisect this side, join that to the opposite point, the center will be somewhere along there. If I did it for another point, which this one is kind of already doing, it'll give it to me. So even though this line is inclined at an angle, even when I bisect it, it's still going to give me a midpoint. It's still going to be halfway along it. So we're going to bisect it the same way that we normally bisect things. So extend over halfway, swing an arc. I'll extend over halfway. Now this is actually larger, but that's fine. That's the midpoint of this side. I can join that to the opposite point. So that gives me this point up here. So that there would be the center point of that face. So the reason I know that is this line here is also bisecting this edge. So that would instead of having to bisect it, it's just giving me that there, skipping a step. Okay, next part of this is to find where they're in contact with each other, we need to draw an auxiliary view. An auxiliary view in this case requires an auxiliary elevation, which is going to require an x3, y3 line. You can call it x1, y1, and it is an x1, y1 line as it's the first of this new view, but just to avoid confusion, I'm calling it an x3, y3 line, so that we know we're not talking about these ones over here. So I'm going to project each of these points up. So at this point, I'm going to project the center point up. That's up along here. And the top one we don't need. But we're going to find the center point again. So we're going to find what that center point is up here because we need to get the height of that. So again, bisecting the same line, so which would be this one, but this time in the elevation. Extend over halfway, swing an arc. And same going the opposite way. So this is the same line that I had down here at the bottom, just finding the elevation now. Projecting the center point up onto that line. That's the center point of B, face B. We need to measure the height of that off the XY line. Mark that up down here. And this will allow me to get the correct slope. So that now is an edge view of the surface B, and the ground circle is going to have to be in contact with this point here. So we're going to draw this circle in here now next. So thinking back to junior cycle graphics, or tech graph, if the center point is, this line is going to be tangential to the circle, so a normal, so a line taken perpendicular to this edge here will contain the center. So our circle is going to, the center of the circle is going to be somewhere along this line. If I want it to be on, if I want it to be touching off this line and this line, I'm going to need to bisect the angle, and the center will also be somewhere on that bisector. So bisector. That point here is a point on the curve, and now we can just draw in our circle. So we can now draw this circle here, that's the center point. So this circle here, it touches, or it's a sphere, touches both faces, touches the ground and face B. Need to locate that down here. So this is the center point, it's going to be on the line coming out along this way. Okay, so perpendicular to that ground line that we brought up earlier. So that's the center point of this here. So again, you can draw this circle in. It's going to be hidden detail for a lot of it, visible around the outside. And then we need to locate this point up in the elevation. So handiest way of finding centers is touching the ground. So if you just measure the height, the radius height up, that'll give us the center point, and then we can draw another sphere here. My hands are kind of in the way, but so this is that sphere then up in that position. And that completes part question A3, one of the longer ones on this paper. Question A4 is so for this question, the plan elevation and end view of an archery target are shown. The line PA represents the plan of an arrow just before it hits the target. The arrow travels horizontally in a straight flight path. Draw the arrow PA in the end view and in the elevation. Determine the projections of the arrow when it hits the target. And a second arrow traveling in a straight line also passes through P and hits the target at the bullseye center point. Determine the true angle between the two flight paths. So looking at the first part of it first, we're just going to take the end point of it, point A, and we're going to find that up in the end view. So the end point of the arrow, we're going to rotate that around up to rotate this and project it up into the elevation. So that it travels horizontally, so that's going to come across this way. So this is the arrow in the end view. Finding that same piece in the elevation, again it's at the same height, it's horizontal. This is the start point of it, it's in line with our center line, and point A is this here. So that's the end view, or sorry, that's the elevation of the arrow for part A. Part B is to determine the projections of the arrow when it hits the target. So if it's traveling in a straight line, it's going to continue along this way. So extending this line here in until it touches. So it's going to be there, but we need to determine where it touches it. We know up here it's going to be somewhere along that line, and in the end view we can determine where it hits it. So it's up here, it's this point. So what we can do next is we're going to take this point and find that now down in plan. Rotate. And this point across here. So this point here is the point of intersection where the arrow enters the board. The distance, the length of the arrow is going to stay the same. That hasn't changed because it's still traveling horizontal, so that means in plan it's a true length. So this distance here is unchanged, as is this distance here. So arrow in the end view, arrow in the plan, and finally arrow in the elevation. So that's part B of the question. Part C, a second arrow travelling in a straight line also passes through point P and hits the target at the bullseye, so through the center point. Determine the true angle between the two flight paths. So what we're going to do is, in the end view, we're going to do this first, joining point P to the center point, the bullseye. That gives us this line here. In plan, that's going to look, this is the flight path of this arrow now, that's going to be here. So I'm traveling until it hits the center point. As we're looking in perpendicular to this in our end view, this line here is a true length. So what we can do is, to find the true angle between the two, is treat this as a lamina, or part of a surface. So we've got a surface joining from P to the point of intersection here to this point down here. So we can take this point here. So we've got a surface going from this point to the bullseye to point P. What we can do is we can rotate that surface. So at the moment it's kind of down a bit like this. So if you take this here in the center, it's like that. What we're going to do is we're going to rotate this over until it's now flat and we can see the true shape of it. So what we need to do is we're going to rotate around this line. So taking this, we're going to go perpendicular to it, and our bullseye point, going to move perpendicular to it, just like all rotations. And how we find out where this is out here is, because this is a true length up here, so the line, this line, the equivalent of this line here, that's a true length. In the end view, we can measure that distance. Taking that distance here, putting it onto the endpoint, point P, and marking it there. This is the new bullseye point. So taking this line out along this way, this is the angle, the true angle between that and this. And that completes the 2017 higher level section A